C2 is basically 1 1 0 and 0 0 is 0. So we have to make this table until we can continue. We can continue until we can end up with all possible combination of states. Okay. So when two delays are present, that means S1 and S2, then that means four combination will be available. That means 0 0, 0 1, 1 0 and 1 1. Okay. So every time you have to consider the present state as 0 0, 0 1, 1 0, 1 1, and you have to consider Mj for each state. We have to consider two values, that 1 and 0. Okay. So in this way, you have to make this table. So you can follow from the book that what I'm telling you. Just let me erase this. Okay, so here you can see that this is 0 0, right? You just follow, this is 0 0, and for 0 0 value, 0 0 state, we are considering this 0 0 as a present state, and for this 0 0 condition, we are considering two possible value of input, which is 0 and 1. Okay. Similarly, for the 0 1, we are considering 0 and 1. For 1 0, we are considering 0 and 1. For 1 1, we are considering 0 and 1. So for each case, we have to consider two possible value of the input, and we have to observe that what is the next step. What is the next step? So in this way, we just making this diagram, which is called the state diagram, and from this, so just I'm just going back to my diagram and written note that let me just erase this all sketches. Okay. So here you can see that this is what I'm telling you, that Mj equals to 0. So we are assuming that 0 0 is the present state for each condition. That means 0 0 for 0 0. That means for 0 0 condition, we are assuming two message bit, which is 0 and 1. Again, for 0 1 condition, we are assuming 0 and 1. Okay, and when we are observing the what will be the next step, that is Pj plus 1. Okay, and this is your state diagram. This is the state diagram. Actually, exactly. So this is your state. So this is your state diagram. So now, how to make it? This is easy because you have already studied in your digital class, that same as this. That means SA, first of all, we have to just write that all the possible combination, that SA equals to 0 0. So you can follow my cursor, that SA equals to 0 0, SB equals to 1 0, SC equals to 0 1, and SD is basically 1 1. Okay, these are the all possible combination of the state of S1 and S2. Right. Now, we are considering the present state, the reset mode state. That means we are considering S1 and S2, which is the value of S1 and S2 is 0 0. Okay. So, what will be the next step? What will be the next step when I'm giving the encoder 0? So it will be 0 because C1 is basically what? M XOR with S2 from the diagram. You can see from the diagram that C1 is basically M XOR with S2. So similarly, 0 0 is 0 and C2 is XOR of three elements. That means M XOR with S1 XOR with S2. So it's all 0. And the next state. What will be the next state? So I've told you that how to calculate the next state. When you are calculating the next state, you have to assume that you have already fed this message bit with new bit, which is 1. Here it is 1. So when I'm feeding this as 1, then the previous bit, which was 0, that 0 will be shifted to S1. Again, what was present at the S1, that will be shifted to S2. So that is your next state. And that next state will be the present state for the next stage when I'm feeding this message input as 1. Okay. So now C1J. So see, what is the value of C1J? C1J is basically the XOR of M with S2. So 1 0 is 1. So that's why this is 1. And this is 1 also. How? It's the XOR of 3 elements. That means 1 XOR with 0, that is 1. And 1 XOR with 0, that is 1. So we are getting both values as 1. Okay. So how to draw this diagram when I'm considering the state diagram? That means when I'm representing this table in a diagram, state diagram, how to represent it? Okay, you can see that I'm considering this is SA equals to 0 0, right? Okay, so SA equals to 0 0. So you can see that this is SA. Okay, SA equals to 0 0. That means this basically represents the present state. That means this SA equals to 0 0. This is representing this present state. Okay. So what is the condition? That the next state will be 0 0. Okay. So the condition is basically the message will be 0. The message should be 0. And C1 and C2 will be 0 0. So this is basically the message equals to 0 and C1 C2 equals to 0 0. So I'm just representing this table in this state diagram. Okay, so you have to just follow how I'm just representing it. So first of all, I'm just written all the possible combination of S1 S2, that are like SA equals to 0 0, SB equals to 1 0, and SC equals to 0 1, and SD equals to 1 1. This is all possible combination because there is a 2 delay, so all the total possible combination will be 4. Okay, so that's why this is total possible combination like SA SB SC SD. Okay, and this is SA equals to 0, which is representing the present value. This, okay, present value this 0. So when the next state will be 0, so we are calculating in this table the next state will be 0 0. So I'm representing, when I'm representing this first row in this diagram, so this is the method, that this is the present state, this is the input, what is the combination, what is the condition when to generate the next state as 0 0. So this is the condition that the message should be 0, the C1 and C2 will be 0 0, and then only we will get the next state as 0 0. So that's why I'm using this self loop. Okay, the present state was 0 0, and the next state is also 0 0 when the message is 0 and the C1 C2 is 0 0. Okay, now similarly, just you can follow that when this is 0 0. Okay, present state is 0 0, and I'm feeding the message as 1. Okay, 1 bit. This is 1 bit. So when I'm giving the message bit as 1, so I'm getting C1J as 1 and C2J as 1. How? Because C1J is basically the XOR of M XOR with S2. So C1J equals to M XOR with S2. So 1 0 is 1, and C2 is basically the XOR of 3 elements. That means 1 0 is 1 and 1 0 is 1. So that means we are getting both of C1J and C2J as 1 1. Okay. So what will be the next step? What will be the next step? So when I'm feeding a new value to the M, the next bit, the previous bit of MJ 1, that was 1, that will be shifted to